So let's talk about factoring. The first type of factoring that I'm going to talk about is what's called reverse FOIL factoring. To remind you what this is, let's first talk about what foiling is. FOIL is a method for multiplying together two binomial expressions like this. And by binomial, I just mean that each expression has two terms. So that's what a binomial expression is. That's what I mean by multiplying two binomial expressions together. And FOIL stands for first, outside, inside, and last. And the way we interpret that is when we go to multiply these two expressions together, we can multiply their first two terms to give us our first term in the product, and then we can multiply the outside terms to give us our second term in our product. We can then multiply the inside terms to give us our third term in our product, and then we can multiply the last two terms to give us the last term in our product. And what we usually do with this is combine like terms, and if you have actual numbers, this will look nicer. But I only have the one x squared term. I have two x terms, and so I would combine the a and the b, and then I have my last constant term ab. And if you had numbers with this, it would look a lot nicer. But so yeah, that's foiling, and the reverse FOIL factoring method is basically reversing this whole process. So one thing that we notice is at the end of foiling, we end up with a quadratic expression. There's an x squared term, there's an x term, there is a constant term that doesn't have an x in it. So if we have a similar quadratic equation, and these are very similar because there's no constant out in front of the x squared, we can reverse this foiling process in order to factor. So the first thing that I do is write down the basic shape of this. I know that I'm going to have an x plus some a and an x plus some b, and it's just kind of my job to figure out what a and b have to be. So I usually begin like this. I write down an x with the parentheses, and I think, okay, how can I fill in the blanks? For this particular problem, what I do with this, and this step requires a little bit of guess and check, I look at this minus 8, and I think to myself, that corresponds to this AB. So I need to find two numbers that when I multiply them together, I get negative 8. Now, this minus 2 here corresponds to this A plus B. So when I add A and B together, I should get negative 2. And I usually just do this by guess and check. If I think about what multiplies together to be minus 8, I could have minus 4 and positive 2. And if I think about adding those two together, minus 4 plus 2 is negative 2. So that will work for my A and my B. So again, you can double check this by foiling that out again and seeing that you get the right thing, but that is the thought process behind reverse FOIL factoring. Now there's other ways of factoring a quadratic equation. The method of grouping is really popular, and I suggest that if you're interested in that, if you don't know it already, you should go look up another YouTube video on that. What I am more interested in talking about at the moment is actually the question of why we factor in the first place. And have you ever thought about that? Why do you factor? It's this algebraic process that I'm sure has been drilled into your head. Why do we do it? The answer is that we want to solve equations. So for example, if we take our quadratic expression, x squared minus 2x minus 8, and we set it equal to 0, this is an equation, and when we solve this equation, we ask ourselves what value of our variable x will make this equation true. and this is a question that is just pervasive in all of mathematics, is how do I solve an equation? The key theorem for understanding this is the following. So for real expressions A and B, when I multiply them together and get 0, I have to have that either A is 0 or B is 0. So let me break this down a little bit for you. First off, what on earth is a theorem? So a theorem just means a deep mathematical property. Basically, all of mathematics is involved with proving theorems, proving these deep mathematical properties. So we have a lot of them. Now, by real expression, what I actually mean is some expression that stands for a real number. So, for example, in the previous example, x minus 4 is a real expression. What I mean is that x is some real number, and I'm subtracting 4 from it. Also, x plus 2 was a real expression. If I have some real number x and I add 2 to it, I get a real number. So these are formulas that represent real numbers. And so what the theorem is saying is that if I take 2 of these real expressions and I multiply them together and I get 0, one of those things has to be 0, or the other one, or both of them. So the meaning for this is, if I take x minus 4 and I multiply it by x plus 2, and it's equal to 0, that is true if and only if, and I'll explain that in a second, x minus 4 is equal to 0, or x minus 2 is equal to 0. So this is what this means in practical terms. Now, this if and only if is a mathematical way of saying that both of these things, both of these statements are true precisely when the other one is true, and false precisely when the other one is false. So they're either both true or both false. So these two statements are inextricably linked with each other. One can only be true if the other one is true, and vice versa. Okay, so let's put this into practice. So we've kind of already solved this, but let's go from the beginning to the end in one step. We want to find all real numbers x such that x squared minus 2x minus 8 is equal to 0. This is what we mean by solving this equation. So what we saw on the last slide is that we want to factor x squared minus 2x minus 8. And we know from the first slide that we can factor that, we can reverse FOIL and get x minus 4x plus 2. And so that is equal to 0 if and only if, so precisely when, x minus 4 is equal to 0 or x plus 2 is equal to 0. So now I can solve both of these. I can add 4 to the first equation and subtract 2 to the second equation on both sides. And what I end up getting is that either x is equal to 4 or x is equal to minus 2. And so if I want to write out my solution in one nice place, I would write x equals 4 comma negative 2. And I can say, yep, I'm done. That's my solution. So that is how factoring comes in, and that is how this theorem comes in that deals with multiplication of real expressions to actually solve this problem. Let's see another example. So what if we wanted to solve this equation? We want to find all real numbers x such that if I take x plus 1 and multiply it by x minus 2 and multiply that by x plus 3 and I set that equal to 0, what numbers x satisfy this equation. So this is a generalization of that theorem because I don't just have an A and a B, I have an a B, and a C. But hopefully you believe me when I say that it really works the same way. If I have A times B times C equal to 0, that means that one of those things has to be equal to 0. So this expression is 0 if and only if x plus 1 is equal to 0, or x minus 2 is equal to 0, or x plus 3 is equal to 0. Remember, these three are real expressions. They stand for real numbers, and if I have three numbers that I multiply together and I get 0, one of those numbers, or maybe two of them, or maybe all three of them, have to be equal to 0. So now I solve these much simpler equations. I'm going to subtract 1 from both sides for this one, and that will give me x is equal to minus 1. In the second equation, I'm going to add 2 to both sides, and that will give me x is equal to 2. In the last equation, I'll subtract 3 from both sides, and that will give me that x is equal to minus 3. And so all in all, we have that our solution set is minus 1, 2, and 3. And that is the answer to our problem. Okay, so again, this was a crash course on why we factor. If you want to look up actual other factoring methods, you will want to find another YouTube video on this, and there are many. Just search for factoring.